Assalamualaikum warahmatullahi wabarakatuh. In this occasion, we want to explain about the camera. Before we explain about the camera, I want to introduce our team. This member is Ahmad Hamka, Muhammad Dzakwan Alifi, Akhyar Abiyu, Dzulkifli Al Fikri, Naufal Hibban, and Muhammad Chafizhun Amin. How a camera is used as an optical instrument. A camera is an optical instrument that forms and records an image of an object. That image may be recorded on film or it may be detected by an electronic sensor that stores that image digitally. Regardless how the image is recorded, all cameras form images in the same basic way, as shown in the figure below.
The mechanism of the camera. A camera captures light photons, usually from the visible spectrum for human viewing, but in general could also be from other portions of the electromagnetic spectrum. All cameras use the same basic design, light enters an enclosed box through a converging or convex lens, and an image is recorded on a light-sensitive medium, mainly a transition metal halide. A shutter mechanism controls the length of time that light can enter the camera. Most cameras also have a viewfinder, which shows the scene to be recorded, and the ability to control focus and exposure so that it is not too bright or too dim.
Aperture. The aperture, sometimes called the diaphragm or iris, is the opening through which light enter the camera, typically located in the lens. This opening can be widened or narrowed to control the amount of light that strikes the film. The aperture is controlled by the movement or overlapping plates or blades that rotate together and apart to shrink and expand the hole at the center. The diameter of the aperture can be set manually, typically by adjusting a dial on the camera body or lens, or automatically based on calculation influenced by an internal light meter.
Shutter. The shutter, along with the aperture, is one of two ways to control the amount of light entering the camera. The shutter determines the duration that the light-sensitive surface is exposed to light. The shutter is open. Light enters the camera and exposes the film or sensor to light, and then the shutter closes.
Lens. The lens of a camera captures the light from the subject and brings it to a focus on the sensor. The design and manufacture of the lens is critical to the quality of the photograph being taken. Camera lenses are made in a wide range of focal lengths. They range from extreme wide angle and standard medium telephoto. Lenses either have a fixed focal length prime lens or a variable focal length zoom lens. Each lens is best suited to a certain type of photography. Then the process of forming an image on the camera. The general working principle of the camera is as follows. The object to be photographed must be in front of the lens. When the diaphragm is opened, light passing through the object enters through the diaphragm opening to the eye lens. The eye lens will form an image of the object. In order for an object's image to fall on the film clearly, the position of the lens must be shifted closer to or away from the film. Shifting the lens of the camera, such as adjusting the focal length of the lens of the eye accommodation, the image information diagram on the camera is shown in the following figure.
Okay, now we have two examples of question for the exercise. Okay, the first question is a camera has a focal length of 80 millimeter, originally used to take a picture of objects that are quite far away. Then the camera used to take a picture of an object that is 2 meters away from the lens. The question is, define and decide where and how for the camera lens should be shifted. Okay, this is the one question, and the second one is the focal length of the lens of the camera is 50 millimeter. The camera is set to focus the image of an object at infinity. The question is, how far must the camera lens move to focus the image of an object that is 2.5 millimeter away? Okay. Without further ado, let's jump to the first question. With this question is a camera has a focal length of the f is 18 millimeter. So it will become 0.08 meter. Okay, and then we know that the s is far away, quite far away. We can initiate that as infinity. Okay, then we have known that the expression is 1 per s plus 1 per s accent is 1 per f. This is the first expression. Okay, we can just known as 1 per infinity because the s is infinity plus 1 per s accent. This is what we're going to known equals 1 per f. The f is 0.08 because we have known before. Okay, as we known before. Okay, then we just count this 1 per s accent because this is it's 0, so it's directly to 1 per 0.08. After this, we know the s accent is 0.08. Okay, matter. This is the first expression that make the s accent is 0.08 millimeter. Okay, then we know the second expression is the same expression but is in different execution. Okay, I will write the same, but we know before the final states of an object is 2 meters away. Okay, 2 meters away from the lenses, of course. So let's include that to the expression 1.2 plus 1.s2 accent equals to 1 per the focus is 0.08. Okay, we count this. We move the 1 per 2 to the right, it will become minus. So per 8 minus 1 per 2. Okay. One per x2 accent is 100 minus 4 per 8. If we count this, it will become as 2 accent. This is 96. Of course, this is 96 equals 0.88. I'm sorry, 0.08083 meters. Okay. Okay. We have known that the focus is 0.08 and the s-axis is 0.083. So, divide this, the shifting of the camera is followed as d equals to s2 accent minus s1 accent. The d is 0.083 minus 0.08. D is 0.003 millimeter. Meter, I'm sorry. Now, if we convert this to the meter, it will become 3.3 millimeter. So, we can shift the camera d.3 millimeter. We know because the S2 accent is greater than S1 accent, and d greater than 0, it means the camera move 3.3 millimeters far away, move away from the film. Okay, that is the first question. We have found this 3.3 millimeter far away from the lens, from the film. Okay, let's jump to the second question. Di pause dulu, Fit. Di pause dulu, Fit, udah. Di pause dulu. Udah? Oke, lanjut ya. Okay, we continue to the second question. Of course, the second question is the focal length of the lens the camera is 50 millimeter. Okay, 50 millimeter. The camera is set to focus the image of an object at infinity. How far must come the lens move to be focus of the image of an object that is 2.5 millimeter away? Okay, when we use to focus objects that are far away at infinity, okay, at infinity, the image of the object will be exactly at the focal point of the lens. Okay, yeah? In another word, it's say that S accent equals to F. Okay, and the focal length is 15 millimeter. Okay, when the object, the S, it means the object distinct from the lens, it means S is equals to 2.5 millimeter away, and we convert that to the meter. Okay, I'm sorry, this is meter. If we convert to millimeter, it's 200 and 205,000 millimeter. Okay, this is follow us the expression is 1 per 1 per s plus 1 per s 10 equals 1 per f. The same expression that we used before. Okay, let's going to find it. 1 per s, the x is 2,500 plus the f accent is 50. I'm sorry, the s, oh, I'm sorry, we going to find the s accent because we find the, oh, we must define how far the camera lens move. Of course, we going to find this s accent. So 1 per s accent is equal to 1 per 50. We're going to find this 1 per s accent. I move this to the right, it will become minus 1 per 200 and 2500. Okay, 2500, and then okay, we move to right side. I'm going to write it again. Okay, we define this and then we will count in the right of equals 1 per s accent equals 2. Fifteen minus 1 per 2500. Okay. Next, we have known this is 49 per 2500. So the S accent is 2500. We will switch this per 49. So the S accent is T1.02 millimeter. Okay, because we will find the how far the length is shifted, so we're going to subtract this, the S accent, by the first focal length. It's 50 millimeter, and the answer is 1.08 millimeter of safety. Okay, I think that's it for the question. I hope you can understand of two questions that we explained before. Okay.
Okay, enough. This is our presentation about the camera. Sorry all of we missed it, and thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.